All right, so here we go with the key for the first part of 4.6. So we did the top part already in class. All right, so we get started with these proofs. It says n is the midpoint of AB, and of course that is given. Looks like I'm going with pink. Fair enough. And then because it's the midpoint, right, well, what does that say? Well, if n is the midpoint, it's saying that those two are going to be congruent. In other words, segment AN is going to be congruent to segment NB, and that is the definition of midpoint. We have AX, which is congruent to NY, and how do I know that? Because it's given, so pretty good there. The second given was the given here. It's another given, so we can just sort of NX is congruent to BY, not done, always marking the diagram. So NX and BY. And so we look here and it says the triangles are congruent, and that's true because we look and we see we have side, side, side. So we have side, side, side congruence. And then finally, because the triangles are congruent, we actually use side, 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 right? We use sort of a side here, a side here, and a side here to prove the triangles are congruent. And now that we know the triangles are congruent, we know that the remaining pieces, in this case, all the angles are congruent, which of course includes the angles that we're looking for right here, angle X and angle Y. So finally, I conclude that angle X is going to be congruent to angle Y because that corresponding parts of congruent triangles are congruent. In other words, the triangles are congruent, so the corresponding parts, which include sides and angles, are going to be congruent. All right. All right, let's go to this one. We have RT is congruent to RV. Okay, so we can say that RT is going to be congruent to RV, and I marked it, of course. And we have TS, which is going to be my next part here. TS is congruent to VS. TS, boom, boom, VS, there it is. It says reflexive, and of course we know that as reflexive property of congruence. We're talking about congruence here because I'm talking about this reflexive side. At least that's what we have been calling it, reflexive side. RS is congruent to RS. And so that is reflexive because it's basically the same side, part of both triangles. Reflexive property of congruence. Awesome. And so we have side, side, side here. Now we would have known that anyway, because the reason they give us is side, side, side. But what is that proving? Oh, that's proving these triangles are congruent. So when we're naming these triangles, we've got to make sure that we name them in order. It doesn't really matter how I start. In other words, if I said triangle RTS, that's fine. R, up top, RTS is fine. And then I have to go and sort of name them the same. So RT would be my corresponding to RV. So I'm going to do RVS. RVS, triangle congruent. Just making sure they match up. You don't have to name it RTS, but you do have to, once you do name the first one, you have to make sure they're matched up. And then finally, look, we used all the sides are congruent. So now we know because the triangles are congruent, that all the remaining angles, and that includes RST, that includes the angles that we're looking for. So we know that those are congruent because of CP, CTC. We know that the angle T and angle V are congruent as well. We know that these two angles, TRS and VRS, are congruent as well. It's just that they happen to ask for the other one. So I could have used CP, CTC multiple times. I didn't. I just didn't need to based on the given information. All right. Looking here, it says that we have VB. So this ray VB bisects, it should probably say segment VB bisects EVO and EBO. In other words, it's bisecting two different angles. So it's bisecting angle EVO, and that's the first given piece of information. And then I see the reason is definition of angle bisector. Well, what does an angle bisector do? It splits a larger angle into two congruent smaller angles. And in this case, those two congruent smaller angles, because EVO is our large angle here, that angle 3 and angle 4 are those two congruent angles. So we know that angle 3 has to be congruent to angle 4. And that is because of the definition of angle bisector. And then we have the other given. Well, we sort of split this one statement up into VB bisects EVO. We can also say that VB is going to bisect the second part here, and that's EBO. And so EBO is this other angle over here with the vertex at B. So EBO here. And so we can see that, because it's bisecting it, it's cutting EBO into two congruent angles. Oops, I guess I should mark it with 3. And so we know that angle 1 and angle 2 are congruent. And so that is the next step, which is nice because we sort of saw that coming. And again, we know the reason why that is because that's what an angle bisector does. So that's the definition of an angle bisector. Okay, finally, we know that BV is congruent to BV. And so that's just going to be reflexive. Hopefully this is sort of instinctual at this point, reflexive property of congruence. And then finally, again, even if I saw this reason as ASA congruence, I'm thinking, oh, that means the triangles are congruent. If the triangles are congruent, that's a reason for triangle congruence. So I just have to say which triangles are congruent. Again, it doesn't really matter which triangle I start with. I'm going to say BEV, just going across the top there. But if I say BEV is congruent to triangle, I'm sorry, if I name the first one as BEV, then I should be corresponding. So in other words, vertex B is actually going to be the same vertex B on the other one, and then it's going to go BOV. So BOV is going to be the triangle based on BEV. And then so finally, because if we look, that was angle side angle. So if we look, it's sort of we have an angle here, we had an angle here being congruent and an angle here being congruent. And remember, it doesn't matter the order in the statement; it matters where it is on the actual on the diagram. So we have two angles and their included side are going to be congruent. That's why it's angle side angle. Even though we proved it as two angles and then a side, it doesn't matter. On the diagram, it's angle side angle, so it's angle side angle. And so we basically use two angles and a side to prove congruent, which means the remaining two sides and one angle are going to be congruent, including angle E and angle O. So angle E and angle O are congruent, again, because that's corresponding parts of congruent triangles are congruent, or CPCTC. All right. All right, so here we go. We got JK is congruent to ML. JK is congruent to ML. That, of course, is a given information. I'm not done with that yet. Got to mark it. JK is congruent to ML. There we go. Then it says the second given, which is our reason there, is going to be angle JKL is congruent to angle MLK. And so MLK is, where is my cursor here? MLK is this angle. Wait, sorry. Yeah, MLK is this angle. And JKL is this angle. Okay. This might be one to look at in sort of a way. Which triangles are we sort of actually referring to here? What we're actually looking at. So if we look, we have J. Sort of that triangle is one that I'm looking at, and then the other one would be, let's I guess use blue is fine. Is going to be sort of this triangle here, and we hopefully see that there's part of this that's overlapping. And there are other triangles we could look to prove congruent. The reason why I'm looking at these is because they flat out tell me that this angle is congruent to this angle, and that this angle is part of this triangle, the blue triangle, and this left angle at vertex K is part of the green triangle. So I have a good idea. It does say KL is congruent to KL, and that sort of solidifies it for me because KL is part of both of these overlapping triangles that I'm looking at. And even if we didn't know that, we just based on the reason, we could say reflexive property of congruence based on just what the statement is itself. But again, it does show sort of that these triangles are congruent. And the triangles are congruent. If I just sort of sketch one of them out here, I say, oh, it's this and this and this angle. So that's going to be side, angle, side. And again, you can see this here because we have a side here, an angle here, and a side here. Again, it doesn't matter the order here. It matters the order where they are in relation to each other on the actual diagram. It's still side, angle, side. We have two sides and the angle between them. So that's the included angle. So we know it's going to be good. And then finally, we're trying to prove that JL is congruent to MK, which are both sides of these two triangles. And because of that, because we know the triangles are congruent, we know that because of CPCTC, that's true, that we can conclude that sort of JL is going to be congruent to MK because those are corresponding parts of the triangles we prove congruent. So they have to be congruent. All right. Let's go a little, there we go. All right, looks like we have the first two given, so let's go ahead and put those in. RT is congruent to RV. Again, you don't always have to start with the givens like this. They can be sort of any, but in this case they did. So RT is congruent to RV, mark them. It says the measure of angle TRS is equal to the measure of angle VRS, and that's given. Now I can't mark that yet. Don't know I don't know if those angles are congruent, but now I do, like based on the next step. So that doesn't look very good. Based on the next step, well, because their measures are equal, then we know that the angles are congruent because that's just the definition of what congruent angles are. And so now I can say, yes, that TRS is indeed, I'm going to use double, is indeed going to be VRS as well. So VRS, there it is. Those two angles are going to be congruent. We can say that, again, we hopefully spot a reflexive side. So we know that RS is going to be congruent to RS because of the reflexive property of congruence. And then because we know that these, we have enough information, we have three parts here. And if we look, we have a side here, we have an angle here. Nope, that's false. We have an angle here is congruent, and then we have another side here. We do have two sides and one angle, and that normally wouldn't be enough to prove it, but based on where they are, we have a side here, right? We have a side here, and the angle that we know is included, so we do know it's side angle side is going to be our why these triangles are congruent and which triangles are congruent. Well, we can actually just say angle RTS, and I'm just going to go across the top RTS, and then so we're going to go back and match up the vertices RVS, so we know it's congruent to triangle RVS. And then because that, it says, well, now that the triangles are congruent, all the remaining sides, the one remaining side and the two remaining angles are going to be congruent, which includes this one, our RST. So RST is this angle over here, and this angle right here are going to be congruent because of CPCTC. In other words, those are corresponding parts of the triangles I already proved congruent. Therefore, they have to be congruent. So prove the triangle is congruent, always a safe bet. And then after that, you're allowed to use CPCTC because we know the triangles are congruent. All right, we say AD is an angle bisector of BA. So BAC right there. So we know that that is going to be my given. Well, I'm going to start there. And I'm going to start there because I know which given I'm referring to. There's two givens, and there's one spot that says given. But I know that it's going to be this one because the next step is definition of angle bisector, meaning I'm going to use the one about angle bisectors. And so we know that this is actually given. And what does that do? What is the definition? What is an angle bisector? So let's use that definition. It says it splits a larger angle, basically, BAC in this case, in half. So this is AD's coming along and splitting into two congruent angles, and those angles happen to be named 1 and 2. So we're going to say angle 1 is congruent to angle 2. Definition of angle bisector there. All right, we have the other given, right? We know it's a given spot, so we only have one left that we didn't use yet. So AB is congruent to AC. Not done with that. Got to mark it, so I'm going to. And hopefully we see, oh, look, we have a reflexive side there, reflexive property of congruence. There it is. So I'm going to go ahead and say AD is going to be congruent to AD. And then they mark the triangles are congruent because if we look, again, I'm just going to sketch out one triangle so we know. We have one side here that's congruent, one side here that's congruent, and we know the included angle is congruent, so that's side angle side right there. And so side angle side congruence. And if we see that, we go back up, we see that, oh yeah, we have actually an angle here and two sides are going to be congruent angle and then two sides. So again, the order here doesn't matter, and we all, of course, know that this doesn't prove congruence if it was in that order. But we have to look to the diagram, and in fact, the angle is included between the two sides. So now that the triangles are congruent, we sort of can say that BD is going to be congruent to DC, right? And that's actually what we're trying to prove, and that's because of CPCTC. In other words, corresponding parts of congruent triangles are indeed congruent. Yeah, exactly. And then if we actually wanted to go further, now that we knew like BD and DC are congruent, we then could say D is the midpoint of BC because that's the definition of midpoint. So we don't necessarily have to be done. Just by doing CPCTC, you can prove an angle or sides are congruent and then go from there and say, oh, then those lines must be parallel, or that must be an angle bisector, or that must be a midpoint or something like that. But in this case, we were done with CPCTC with the ending one here. All right, I'll see you at the next one.